Hey everyone, welcome to this explainer. Look, if you've ever just sat there staring at your screen in pure frustration, wrestling with a messy, completely unpredictable local development environment where your code works perfectly on your machine but literally nowhere else, well, you are definitely not alone. It's kind of considered a rite of passage, but honestly, it doesn't have to be your permanent reality. So let's dive right in and fix that once and for all.
Because this right here is the million-dollar question, isn't it? What does a professional-grade container workspace actually look like? Well, today we're going to answer that by building one completely from the ground up. By the end of our journey together, you're going to understand exactly how to assemble a streamlined, totally professional setup that lets you build, test, and orchestrate containerized software flawlessly right on your own machine.
Okay, here is our roadmap for today. Step 1, laying the digital foundation. 2, equipping your developer toolkit. 3, powering up container engines. 4, orchestrating with local Kubernetes. And finally, step 5, testing your working environment.
Let's get right into section 1, laying the digital foundation, operating systems, and shells.
So, you probably know Docker is available across the big three, macOS, Windows, and Linux. But it's super important to remember that containers were originally developed on Linux specifically for Linux. And because neither Windows nor macOS can run Linux containers natively right out of the box, each of these environments has its own specific quirks and requirements to actually make the magic happen.
And this breakdown brilliantly illustrates exactly what you're going to need based on your specific machine. If you're on a Mac, you really just need to pay attention to whether you've got an Intel chip or Apple Silicon, because that dictates your OS version requirements. Now, for Windows users, your sweet spot is Windows 10 or 11 Pro or Enterprise. And listen, you will definitely want to leverage WSL2, that's the Windows subsystem for Linux, for a truly seamless high-performance experience. And hey, if you're already on Linux, you just need a modern distribution that supports groups and namespaces, and you can just install the engine directly. So identify your hardware right here, and boom, you've got your foundation.
Moving on to Section 2, equipping your developer toolkit, package managers, and editors.
Right, so this is where package managers come into play. Basically, they automate all your software installations. On macOS, you typically use Homebrew. On Linux, you're probably used to apt or yum. But let's look at Windows using Chocolatey as a prime example here. With just a few quick PowerShell commands, you bypass manual downloads entirely. You just set your execution policy, run the install string, and verify it. It is automated, it's repeatable, and it completely eliminates that whole, oops, I clicked the wrong download button problem. Once you've got your package manager running, you use it to grab your essential tools. Obviously, you're going to need Git for version control. Then, you need a really solid editor. Visual Studio Code is the industry heavyweight right now. I mean, it's free, it's lightweight, and it's incredibly versatile. You'll definitely want to load it up with extensions for Docker and whatever specific languages you write in. But what is truly fascinating today is the integration of AI. Tools like Cursor.ai are basically considered essential now. It acts like an intelligent assistant right inside your editor, giving you real-time, context-aware code suggestions. Honestly, it's an absolute game changer for your daily workflow.
All right, Section 3, powering up container engines, Docker versus Podman. But wait, before we just go and install the first thing we see, we actually face a pretty critical choice in today's landscape. Do we stick with the industry standard Docker, or do we pivot to its super popular open source alternative, Podman?
Let's just look at the facts here. Docker Desktop offers this highly polished, incredibly mature ecosystem with fantastic graphical interfaces for Mac and Windows. Podman, on the other hand, boasts a daemonless and rootless architecture. What does that mean? Well, it means it doesn't need a heavy background service running all the time, and it can run containers without root privileges, which, as you can guess, is a massive win for security. Plus, it's fully compatible with Docker command line instructions. The trade-off, though, Podman has fairly limited native GUI tools and usually requires a bit more manual configuration on Windows and Mac compared to Docker Desktop's one-click magic. Look, both are absolutely excellent. It really just depends on your specific needs for security versus out-of-the-box ease of use.
Now, for the purposes of this explainer, we're going to proceed with Docker Desktop, just to get you up and running as quickly as possible. You literally just head over to docker.com, sign in or create a free account, and download the specific package that matches the architecture we identified back in our foundation step. Easy enough.
Okay, let's dive into this terminal output. Because once it's installed, we don't just assume it works, right? We prove it. By opening up your terminal and typing docker container run hello world, you trigger the system. And what you're seeing right here is the visual proof that the Docker daemon successfully reached out to Docker Hub, pulled down the Hello World image because it couldn't find it locally, created a container, and executed it just to give us that hello from Docker message.
And, just to have a little bit of fun and prove that first one wasn't a total fluke, we can run another test image. Just type docker container run rancher/cow hello. Seeing this classic ASCII cow pop up in your terminal is undeniable proof that your local engine is successfully downloading images, executing them, and streaming the output right back to your screen. Your engine is fully operational.
Now let's translate what we just did in the command line into a much more visual format. If you open up the Docker desktop dashboard and click over to the Containers tab, it brilliantly illustrates the exact containers we just ran. You can see the Hello World and Cowsay containers sitting right there, both now showing an exited status because, well, they finished their specific tasks. It's just a really great way to visually keep track of your whole environment.
Next up is Section 4, Orchestrating with Local Kubernetes, Minikube, and Kind. So that orchestration system we mentioned, that's Kubernetes. As defined here, it's a powerful platform for automating the deployment, scaling, and management of containerized applications. Basically, when you move from running a single container on your laptop to dozens or even hundreds in a production environment, you need Kubernetes. And to develop for that effectively, you need a way to simulate that complex Kubernetes environment right here on your local machine. Luckily, we have a couple of really great tools to do exactly this: Minikube and Kind. Now, Minikube is fantastic. It defaults to provisioning a single-node Kubernetes cluster on your workstation, but it can totally handle multi-node setups too, using a hypervisor or just Docker itself. Then there's Kind, which stands for Kubernetes in Docker. It's another incredible tool that actually uses Docker containers themselves to act as the nodes of your local Kubernetes cluster. Both of these are excellent alternatives, depending entirely on how complex you need your local testing to be. However, if you already installed Docker Desktop, you might not need to install any extra tools at all. Just look at how incredibly simple this is. Right inside the Docker Desktop settings, under the Kubernetes tab, there's literally a toggle switch that just says Enable Kubernetes. You click that, hit Apply and Restart, and Docker will automatically download the necessary infrastructure and spin up a local single-node Kubernetes cluster for you behind the scenes. No way it could be easier, right?
But let's say you don't have Docker Desktop, or maybe you specifically want to use Minikube to test out multi-node deployments. If you go the Minikube route, you're going to be presented with an installation matrix. And the absolutely crucial point here is that you must carefully match your operating system, your system architecture, like ARM64 if you're on Apple Silicon, and your preferred installer type, like Homebrew. Taking a second to get this matrix right ensures a completely smooth installation.
And finally, Section 5, Testing your working environment, proving the setup.
So once your local cluster is up and running, whether you went through Docker, Minikube, or Kind, you're going to use a command line tool called kubectl to talk to it. By running kubectl config get contexts, you reach a really crucial checkpoint. This output shows you all the clusters your system actually knows about. And see that little asterisk? That tells you exactly which one your commands are currently targeting. You always want to make sure you are talking to the correct local cluster before you start deploying code.
Okay, now for our final verification. By running kubectl get nodes, we're asking Kubernetes to report back on the status of our system. And seeing that ready status pop up right there, that is the final visual proof we need. It confirms that the control plane is active, the nodes are talking to each other, and our professional-grade environment is fully 100% functional. You have officially eliminated the guesswork. You've got the right OS setup, automated package managers, a cutting-edge AI-powered editor, a proven container engine, and a fully functional local Kubernetes cluster. Those incredibly frustrating days of, well, it works on my machine, are completely behind you. So I'm going to leave you with this one thought. Now that your Master Builder's Toolkit is completely assembled and tested, what will you build first?